So this is the lecture on DBMS normalization, and we have already covered first normal form, second normal form, and today our topic is third normal form. Okay, 3NF. So to have an idea about three normal form, then please go through the first normal form and second normal form. The link for those videos you will find in the description box below. Okay, so let's start. So third normal form. A relation will be in third normal form if it is already in two normal form, means second normal form, and not contain any transitive partial dependency. Or I can say transitive dependency. To remember that when we talk about the third normal form, the first most thing that should come to your mind is that transitive dependency, and that is not allowed here. Okay. So what is actually transitive dependency? Let me give you an idea. Just take an example. X implies Y, okay? Y implies Z, okay? Then X implies Z. So this means to say that transitivity, you know, if this two holds, then this also holds. But how actually it is present in a table, we'll go through an example. Okay, so don't worry about that, we'll go through it. Then let's discuss about some features on third normal form. Third normal form is used to reduce the data duplication. It is also used to achieve the data integrity. These facts we have already discussed actually in some previous lectures. Obviously for this purpose, that is the data duplication is not allowed, or I mean to say indirectly that we tend to decrease or reduce the redundancy. That's why we need normalization. Okay, and data integrity is also very important fact. Okay, then if there is no transitive dependency for non-prime attributes, then the relation will be in third normal form. So this is the case of transitivity. If this is not present, of course the relation will be in third normal form. Now we have some conditions to prove whether the given relation is in third normal form or not. Let's check about that. A relation is in third normal form if it holds at least one of the following conditions for every non-trivial functional dependency. Guys, the concept of functional dependency is very important, and in case of functional dependency you have trivial functional dependency and non-trivial functional dependency. Okay, that also I have already covered in previous lecture. You'll find in the list below, okay, in the description box. So we are now considering a functional dependency X implies Y. Okay, now this will be in third normal form if X is a super key, means if X is a super key. Can I rub this? Okay, because that will help you to understand things better. Consider X implies Y. You all know this is a functional dependency. Okay, now this one is non-trivial, of course. If X is a super key, then this will be in third normal form. This is first condition. Or if this is not satisfied, then also we have another condition that Y is a prime attribute, that is each element of Y is a part of some candidate key. So if this is not satisfied, suppose means X is not a super key, then we need to check that whether Y is a prime attribute or not. And you know what is prime attribute? So prime attribute, as we have discussed before, prime attribute means suppose we have a candidate key, say that is formed with X1, Y1. Just for an example taken, this is a candidate key. Or then you know that this candidate key is formed with X1 attribute and Y1 attribute. Then each of them will be known as prime attribute. So if this part is a prime attribute, then also we can claim that this particular functional dependency is in third normal form. Clear? And this thing you have to remember as per solving the problems related to third normal form. Clear? So now let's take an example. sorry. So now to have a detailed analysis of the third normal form, I am taking a table, I am considering a table that is faculty detail table. Means this table will give you information about the faculty. So every faculty may have faculty ID, faculty name, then zip, then state, then city. This all together give us what? Address. Okay. Then we are taking some values, FID, then for the F names, let's say Lina, Jaya, Kamal, File, Pankaj, like that. Then for zip you know that pin code. Okay. These are also taken randomly. Then some states names as MP, Maharashtra, UP, Rajasthan, Himachal Pradesh, like that. Okay. So then FCT, in the state also we have some cities like Bhopal, Nagpur, Kanpur, Jaipur, Shimla, like that. Okay. So look at this table very carefully, or even you can take a snapshot or screenshot of the same. Can I say that this table is in third normal form? No, of course not. Why? See, although FID is the key here, means primary key here, because you will see that FID can, with the help of FID, we can retrieve all other informations, all the values of other attributes. But then we need to check whether some other attributes exist, non-prime attributes of no doubt, that are deriving some other non-prime attributes. Let's check. See, what happens if you know FZIP? Means if you have the pin code, then you can directly find out the city name, and if you find the city name as well as you will get the state name also, isn't it? So I can say that FID, let me write here, FID is deriving FZIP. You know that, isn't it? But FZIP is deriving what, say I am considering FCT, isn't it? But FID can also derive FCT. Clear? So what happens? The first thing, as I have told you, that transitive dependency, it is clearly present here. See, FID implies FZIP, FZIP implies FCT, and although they present, this is also present, FID implies FCT in this table, isn't it? So this means what? X implies Y, Y implies Z, these two exist, and then we got X implies Z also present in this table. So transitive dependency exists in this table. Hereby we can say that the table is not in third normal form. Clear? Now what to do? We need to convert it into a third normal form. For that, what we will do? We'll break the table. The main problem you have seen that is with this attribute and related to those attributes being derived from this. Then why not break this table consisting of these three attributes in a different table? That's the thing actually we are doing here. See, faculty, this should be zip, okay, faculty zip table, and here I am including FZIP, FState, and FCT. Now FZIP will be our candidate key, isn't it? And it is deriving all the attributes, other values. Okay, no transitive dependency exists in this table, so we can claim that this table is in third normal form. Then other values I am including here in the faculty table. Here FID, FNAME, and FZIP. FID is implying FNAME, FID is implying FZIP, and there is no transitive dependency exists in this faculty table, isn't it? So FID being the key, so we can say that this table is also in third normal form. So guys, you have seen that how a non-3NF table we have broken into two different tables to remove the transitive dependency that exists earlier in the original table to make this table satisfy the three normal form or third normal form condition. Clear? So by this example, I hope this concept is very clear to you. Still, if there are some doubts exist, then don't hesitate to ask me through comment. Okay, comment box is for that purpose. Utilize it properly. So guys, we'll meet in the next lecture. Till then, take care. Bye bye.